So what is this digital signature? We will quickly go over it because these are all foundational concepts that help us to understand better blockchain technology. That's why I'm quickly going over it. So now let's understand digital signature. So here in digital signature, what happens is, let's say there are two users, Alice and Bob, and Alice wants to send data, which is this, to Bob, right? So before sending this data to Bob, Alice wants to sign it digitally, right? So how it happens is, so digital signature is a two-step process. In the first step, what happens is, this data that Alice wants to send is actually first hash. So this is step number one. So here you, after hashing, you get a hash value, right? So here is the hash value that you get after hashing. And in the second step, this hash value is then encrypted using the private key of the Alice. So remember, blockchain uses asymmetric cryptography where you have a public private key pair. So you have a public key, right? So P1 is, let's say, public key, and then you have a private. So let's say another key is PV, private key, right? So the private key is being used by the Alice to encrypt the hash value to get the digital signature, right? So one more time, so Alice takes the data, hashes that data to get a hash value, and then uses the private key to encrypt this hash value to get the digital signature. All right. Then this digital signature is clubbed together with the data, and this new document, which is now digitally signed, is sent to Bob. Now, how does Bob verifies that this data is actually coming from Alice and not from somebody else? How does Bob verifies? Let's see that. So what does Bob does is, it takes the data and it hashes the data to get the hash value, right? So this is, let's say, hash value 1. Then what it does, it has the digital signature which it has received from the Alice. It takes the digital signature, decrypts this digital signature using the public key of the Alice. Remember, Alice has a two key. Public key is actually shared with everyone, and private key is only with the Alice. So this public key is known to Bob. So Bob takes the public key of the Alice and decrypts the digital signature using this public key of Alice and gets hash value 1 and hash value 2. If these two hash values are same, it implies that it is actually Alice which has sent this document, right? So this is very basic explanation of digital signature, right? Remember, digital signature is a two-step function, right? It's a two-step process. First is computation of the hash, and then encryption of the hash value using the private key, right? And the reverse of that at the other end. All right. The third important, I would say the third important concept that blockchain makes use is Merkle tree. What is this Merkle tree? Merkle tree is a way to compactly represent all the transactions, and I'll come to it at a later point. Let's quickly understand how the Merkle tree is constructed and what it does, right? So what it does, it takes all the data blocks. Let's say there are four data that you want to, or there are four transactions that you want to, represent using one value, right? That's what is the aim of Merkle tree. So there are four different these data blocks: data block 1, data block 2, data block 3, data block 4, right? Now here again, Merkle tree uses hash, right? So it hashes this data to get the hash of this data, and this is represented as hash L1, hash of L1 data, right? So this is again in the similar way is the hash of L2, this is hash of L3, and this is hash of this, right? Now another level of hashing is done by taking together these two hash values, right? So it takes this hash value and clubs them together and computes a hash. So this hash is actually the hash of these two hashes. In the similar way, this hash is the hash of these two hashes, right? And ultimately, at the root of this inverted tree, you will have the root hash, which is called as Merkle tree root. This is the hash value that actually compactly represents all these data values. If you change one single bit here in any of the data block, the corresponding hash value will change. Let's say I change one bit here in this block, right? Then this hash will change. If this hash will change, then this hash should change. If this hash changes, then this hash should change. So this is a kind of an avalanche effect that will happen, and this change will ripple down to the root of the Merkle tree, right? So this is another important concept coming from the world of cryptography that blockchain uses. All right. So far we have covered basic concepts that comes from the world of cryptography that blockchain makes use of, right? Now let's discuss Bitcoin, the much heard cryptocurrency, right? So most of the time when people talk about blockchain, they actually talk about Bitcoin. So the question is, are the two same? Is Bitcoin same as blockchain, or they are different, and how they are related, right? So I'll try to quickly give an answer to this question. So what happened is, in the year 2008, Satoshi Nakamoto, which is a pseudonym. So Satoshi Nakamoto is the one who actually, created Bitcoin, the cryptocurrency. But interestingly, nobody till date knows that who is Satoshi Nakamoto. That means, is he a person, or is he an organization or a group of people? We don't know so far, right? So Satoshi Nakamoto created Bitcoin, the cryptocurrency, in 2008, right? So before that, blockchain technology didn't exist, right? So of course, the Bitcoin is the first use case of the blockchain technology, but it is not blockchain technology, right? So the underlying concept or the underlying technology which fuels the Bitcoin cryptocurrency is blockchain technology, right? So there are other use cases of the blockchain technology as well, but Bitcoin is the first inceptional use case of blockchain technology. All right. So I hope I have made a little distinction between the Bitcoin and the blockchain. So blockchain is an underlying technology that helps Bitcoin to work, but blockchain is not Bitcoin. Bitcoin is just one use case of blockchain technology. All right. And it is actually the first use case of the blockchain technology. So when the Bitcoin was launched and when people started using it and they understood how it works, then they found that there is much more interesting underlying technology that can be used in different scenarios and not just in cryptocurrency. And then the blockchain was found. All right. Interestingly, there is not just one cryptocurrency, there are about more than 1,000 cryptocurrencies so far, right? However, Bitcoin is the one of the most popular cryptocurrency, right? So the market share of the Bitcoin is till date dominating. Of course, these figures might be little over dated, but still, Bitcoin is the one which holds the majority of the market share. The other cryptocurrencies are Ethereum, Ripple, Bitcash, Bitcoin Cash, Zen, and so on and so forth, right? You can go and look for these interesting cryptocurrencies and how they're taking over the market, right? Let's see like what is blockchain and where the word comes from. So what happens is all these transactions, that are happening within a certain time duration, they are all bundled up together, and all these set of transactions are bundled up and they are called as block, right? So I'm trying to give you a very first level introduction to blockchain, the word block and chain itself, and how it gives you an intuitive idea about what blockchain is, right? So a set of transactions are bundled together and they are called as block, right? Then you have these blocks connected with other blocks, right? And the way they are connected is that the hash of this block, so remember we discussed about hashing, the hash of this block is actually stored in the next block, right? So blocks are actually connected using hash based chain, right? So this is a logical chain, which is, you must have heard about linked list as well, right? So it's a similar concept where the hash of the previous block is stored in this block. The hash of this block is then stored in this block, right? That's how these blocks are chained together. This chain is actually a cryptographic chain of hashes, right? And since the blockchain intensively uses cryptography, the entire system or the blockchain ecosystem is very much secure. It's cryptographically sealed. All right. Okay. So now I hope you understand where the nomenclature of the word blockchain comes from. So there is a block, and they are all these blocks are connected together using the hash-based chain, right? All right. So now let's try to understand blockchain with the different perspectives, right? So the first perspective is a distributed ledger technology. So blockchain is a distributed ledger technology where ledger is simply simply a system that holds all the transactions that have occurred in the past, right? So everywhere in business we have a ledger. That means you have a debit and a credit, and which goes here and there. So all the logs of all the transactions are stored in a ledger. Now blockchain is a type of a digital distributed ledger technology, right? Why it is so? Because all these block which are chained together, they form a digital ledger, and this digital ledger is actually distributed with all the nodes in the network. So every node in the network is actually having a copy of a blockchain, which is a digital ledger, right? So it's a ledger which is secure and distribute and is maintained in a distributed way. All right. So that's a one perspective. Another perspective is that a blockchain is a data structure as well, right? So transactions are all bundled together in a unit which is called as block, and these blocks are actually linked together using a cryptographic chain of hashes, right? So the way the blockchain is created and maintained, the data structure viewpoint also is another way to understand blockchain, right? The third viewpoint is a technological viewpoint. So blockchain technology, so blockchain usually is used with the word technology. So is the blockchain technology an absolutely a new technology, or it has evolved over the years? I would say that the blockchain technology is not entirely a new technology. It's a powerful mix or amalgamation of the technologies that are underlying the blockchain, right? And these technologies come from the world of cryptography, as we just now discussed, the PKI, which is public key cryptography, that is asymmetric cryptography, public private key hashing, digital signature, Merkle tree, etc., right? Also, it makes use of another technology which is called as peer-to-peer networking, where nodes are connected at an application layer, right? At an application level. So this is what is called as peer-to-peer networking. The other technologies or the concepts that are used for creating blockchain technology are called as consensus algorithm, right? How the nodes in this blockchain network, blockchain peer-to-peer network, they agree on the state of the blockchain. That means the state of this database, right? Also the economic models that drives this blockchain technology, and as well as smart contracts, right? So there is no just one way to explain what blockchain is. There are different perspectives using which we can explain what blockchain is, right? So blockchain is a distributed ledger technology. It's a form of a distributed ledger technology. There can be other ways to implement distributed ledger technology. So blockchain is one of the way to implement distributed ledger technology. Another viewpoint is the data structure, the way the transactions are bundled together and recorded and chained together. Another viewpoint is a technology viewpoint, where technologies are used and underlies this blockchain. So now comes the heart of the blockchain. That means how the entire thing works. What is the process flow of the blockchain system, right? How does it works? All right. So please stay with me now, because it would be connecting everything together now, whatever we have discussed so far. So let us say you have two users. These are Bob and Alice, right? Now, Bob wants to send certain digital value, let's say certain Bitcoin to Alice, right? So when like any other digital wallet, the blockchain will also allow you to have a digital wallet, right? So Bob has a wallet that has multiple addresses, right? These addresses are most of the time the public key of this user Bob, right? So this is Bob and this is Alice. All right. Now, when Bob wants to transfer, let's say X Bitcoin to Alice, it creates a transaction and it digitally signs that transaction with its own public key, right? So it creates a transaction, puts the value in that transaction that I want to transfer X Bitcoins to Alice, and then digitally signs that transaction using its own public key. So far, the Bob has simply created a transaction and nothing has happened, right? It is just creating a transaction, right? Now, second process is that this transaction is sent or broadcasted to the peer-to-peer decentralized blockchain network. Why decentralized? Remember, we talked about the centralized systems where everything is housed and is under the control of one single authority. In blockchain, there is no single authority and there are many nodes in the network, and everybody is taking part in the network and is participating in the management and rolling off the blockchain network. All right. So this transaction that Bob wants to send certain Bitcoin to Alice is created and it is actually broadcasted to the blockchain peer-to-peer decentralized network. All right. All these transactions, like what Bob has just now created, there must be other users also. They must be also creating transactions and sending it to the blockchain system. So all the transactions that happens within a certain time duration, that time duration depends upon the which blockchain platform you're using. In Bitcoin, it is 10 minutes. So every 10 minutes, all the transactions are processed and they are confirmed, right? So for 10 minutes, all these transactions are collected in a pool of unconfirmed transactions, right? So like Bob, other users must also be sending transactions. They are all collected in a pool of unconfirmed transactions. All right, good. Now, these transactions are then picked up by the miners. Now, what are these miners? So miners are actually the nodes, and they are highly computational nodes, which are actually maintaining and managing the entire blockchain system. So if you compare it with the bank system, let's say the bank have their centralized servers where you are not allowed to participate and you cannot put your database or your servers in their premises, right? But here in blockchain technology, there is no central authority. Anyone who has computational capability can join the network and can become a miner. Miner means you are now able to participate in the process of creating a new block, which is called as mining. All right. So these unconfirmed transactions, all these unconfirmed transactions are picked up by the miners, which are across the globe. And you never know how many miners are there at a particular instant of time, as anybody can join the system and they can leave the system, right? So These unconfirmed transactions are then picked up by these miners, which are spread across the globe. And the first thing they do is they verify and validate these transactions. What does this mean? It means that first they ensure that the person who is sending the transaction, that is Bob, is a valid user. It is the Bob who has actually signed and sent the transaction. And second, if let's say Bob wants to send $10 or let's say 10 Bitcoins to Alice, then the Bob should have these 10 Bitcoins with him at the first place, right? So these miners will verify, that means they will verify both the sender and the recipient, whether they are valid or not. And second, they will check whether the Bob will has that digital value, or that means that Bitcoins, that much Bitcoins which the Bob is willing to transmit or transfer to Alice or not, right? Once they have verified these transactions, all these transactions which are unconfirmed, they will then create a Merkle tree, right? And all the transactions are at the leaf node, and progressively they will compute the hash of these transactions, and they will form, and they will compute all these miners parallelly. They will not talk with each other, they will just parallelly and individually will carry out this mining process, right? They will verify individually all these unconfirmed transactions, then they will create a Merkle tree, and then they will compute a Merkle root hash. All right, then once the block is ready for mining, they start solving a crypto puzzle. What is this crypto puzzle? Is, if you remember, there is a field in the block header which is called as nonce. So all the miners start trying different random values for nonce, such that the hash value, whatever they are getting, they satisfy the difficulty level. And the difficulty level is how many initial leading bits the system wants to be 0. If the n bit, which is a representation of the difficulty level, is 10, that means the system right now wants a block hash such that first 10 bits of the hash value should be 0. So all these miners, at the massive hashing rate, they they try different nonce value, and they keep on computing different hash value and matches with the difficulty level. The moment they get this condition satisfied, that means any one of them, any one of the miner, if manages to find out a hash value that meets the constraint, which is the difficulty level, that miner is set to solve the cryptographic puzzle. All right, so the moment any miner is able to find out a hash value such that the difficulty level is reached, then a new block is formed. That miner, which is the winner, creates a new block, and it puts all the transactions, the hash of the previous block which is existing. Previous means just the last block which is there in the blockchain right now, blockchain database. That hash value is put in that block, and the block header is created using the block hash value, and this new block is then formed. This new block is then sent by the winning miner to all the other miners in the network, right? So this new block is broadcasted to all the other miners by the winning miner, so that they should also verify that whatever this miner is announcing, that it is able to, that it has found a hash value which meets the difficulty level, is true, right? A miner can also fake that, it has able to find out the hash value which meets, but it might not be so. So a malicious miner can also be there in the system. But this way of broadcasting this new block and asking all the other miners in the decentralized peer-to-peer network to verify that new block is what is the power of the blockchain technology. All right. So then all these miners, when they receive a new block, they also do the same process. That means they apply that nonce value, they compute the hash value, and they also see that this hash value actually meets the difficulty level. And once all the miners are able to verify and validate the manifestation done by the winning miner, then the consensus is set to be established. All right. So other miners are also in agreement with the winning miner that yes, this new block is actually created and it's true and it's valid, right? The moment this consensus is established, the winning miner who was the first to create the block, that means who was the first to find out the hash value that meets the difficulty level, gets the reward in terms of bitcoins, right? So when the blockchain started in the year 2009, so actually the bitcoin was so right now I am synonymously using bitcoin and blockchain at the same time, because I'm using blockchain bitcoin as a base to explain blockchain, right? So please understand that the blockchain and Bitcoin are different, but right now I am making use of blockchain. I am making use of Bitcoin to explain blockchain technology. All right. So that is why I am synonymously using blockchain and Bitcoin. All right. So I was talking about these rewards, right? So blockchain or Bitcoin was introduced in the year 2008, and the first block was mined in the year 2009, right? So blockchain system actually has its own currency, which is Bitcoin, right? For the Bitcoin system. These new Bitcoins are mined every time a new block is created. All right. So in the year 2000, if I remember it correctly, in the year 2008, it started with the, the reward as 50 Bitcoins, right? Every 4 years, this reward is getting half, right? So in 2008, it was 50. So 9, 10, 11, 12, in year 2012, it became 25. Then in 2016, it became 12.5. And today, it changed in the year 2020, which is this year, in the month of May probably. And right now the rewards that a miner gets when it mines a new block, that means when it creates a new block, is 6.25 Bitcoin. This is small as compared to what the reward a miner used to get in year 2008, but if you see the equivalent value, it is still huge, right? That is why everywhere across the globe there are blockchain mining farms, there are Bitcoin mining farms which are putting massive amount of facility, hashing facility, to create a new block and to get this reward. All right. Once the new block is created, you see this new block is then appended to the existing blockchain. So this is an existing blockchain, and this new block, which has got the consensus of the network, the entire decentralized network, is then appended in the blockchain. Now, where is this blockchain? It is with every miner. So every miner has exactly same copy of the blockchain ledger. So that means every miner has this blockchain, and this new block is then appended by each and every miner which has a copy of the digital ledger, that is blockchain, right? So as I told before, you can create and append only a new block. You cannot modify any of the block that has been put onto the blockchain. Once this new block has been connected in the blockchain, then it becomes enormously difficult to alter any data. Because if you alter one transaction here, imagine some malicious node in the network try to alter one transaction in this. If it alters one transaction, then the Merkle tree root of that block will change. If the Merkle root of that block will change, the block hash will change. If this block has changed, then this block hash which is stored here has to change. Then everything, so it will ripple down and the entire blockchain will collapse. So once the data is put onto the blockchain, we say it is immutable. All right, good. So once the new block is appended and and the blockchain is updated, the Bob gets a confirmation that the transaction has been processed and Alice gets credited with Bitcoin. So this is what is the entire flow of the blockchain. All right, I'll quickly recap. So Bob creates a transaction. All the other users also create transactions. They all submit these transactions. That means they broadcast it to a blockchain network, and a pool of unconfirmed transaction is created. After a particular duration of time, all these unconfirmed transactions are picked up by the miners across the globe. They then verify every transaction and validates the transaction, creates a Merkle root hash, and then start mining. That means start finding the hash value such that it meets the difficulty level, and they keep on changing the value of nonce. Anyone in this race, any miner who is able to find out the first hash value such that it meets the difficulty level announces to all the other miners in the network that it has created a new block, and the new block is broadcasted. Every other miner in the network is then validates that block, and then if everyone gives their consensus and the consensus is established, the winning miner gets the reward, and the block is added or appended to the blockchain system, and both the parties get confirmation, right? Now here you see there is a no intermediary, there are no payment gateways. The transaction directly happens between Bob and Alice, right? Okay, so so the next question is, what is a smart contract, and then how it has kind of improved the scope of blockchain technology, and why everything is moving towards the decentralized applications which are created using blockchain as a platform, and building up smart contracts that helps building these decentralized applications which are acronymed as DApps. All right, so in fact, as I said before, so the blockchain technology is is not the technology that has come up altogether new. It is I would say a result of many different concepts that have evolved over the years, right? So interestingly, if you see the smart contracts which are these days clubbed always with blockchain applications, they were actually created by Nick Szabo in the year 1994, and you know, they are one of the most popular one of the most utilized applications of the blockchain technology today, right? So what are these smart contracts? They are basically computer programs that encodes all the terms and conditions that happens between the two parties. So all the agreements, all the legal agreements are encoded, and they are put into a code, and this code is then put onto the blockchain, right? So uh, so if you compare this smart contract with the traditional softwares, then these traditional software, they run in one centralized systems and servers, whereas these smart contracts, they are actually running in a decentralized system, right? So all the nodes have the have the code with them, and which encodes all the terms and conditions and the of the legal agreement that happens between the two entities. And this brings the level of autonomy to blockchain systems which are decentralized systems, right? So in these smart contracts, or in these codes, in these computer programs which are put on the blockchain system, you can define, you can predefine certain states, right? And then you deploy these smart contracts on the blockchain system. In future, whenever these conditions are met, and whenever these conditions are met, these smart contracts are triggered and they are self-executed. This brings the autonomy to the system, right? So blockchain runs on the top of, so the smart contracts run on the top of the blockchain infrastructure, and they bring autonomy and they help us create decentralized applications, right? Which are more secure and which are temper proof, immutable, and we'll see like different advantages of the blockchain system. All right. So let's quickly go through the salient features of the blockchain system. So normally, these days enterprises and companies, they are looking to take their system and map it to the blockchain, and leverage the blockchain technology and map their existing business processes over the blockchain system. So what all advantages they can get? The point is, not all the systems may use all the advantages. You might be interested in one or two of them, and that is more than enough for you. But there are a set of salient features that blockchain technology brings, right? So let's look at each of them. So decentralized systems, right? So blockchain, as I said before, are decentralized systems, right? Uh, So decentralized systems means the nodes, all the nodes in the network, they are actually having no control completely over the system. They are all together managing this system, right? So another way to understand a decentralized system is that there is no central authority that takes the decision. All the nodes which are participating, that means the miners, these nodes are called miners, all the miners in the network, they are able to take decision in the sense that they can create new block. Anyone can create a new block and append to the existing blockchain. All right. So it got,
We cannot see the screen. Yes.
yeah, so just a minute. So yeah, this, just a minute. Let me just bring back. Is it visible?
Yes, yes. Now it's fine.
Okay, good. Okay, so let me get my pointer. All right. Okay. So yeah, coming back to decentralization or decentralized system. So with peer-to-peer networking and with a distributed copy of the ledger, decentralized implies that there is no central control, right? Any node in the network can create a new content, that is a block, and send it to other nodes, right? That's what is the decentralized system. And interestingly, there is no authority that controls. Everyone together, they collaborate and builds up the system and keeps rolling the entire system, right? Next is enhanced security. So enhanced security is basically coming from the underlying cryptographic concepts, right? So all these concepts that we just went through today, hashing and digital signature and Merkle tree and time stamping, etc., they help to improve the security of the system. And at the same time, since it is a decentralized system, there is no single point of attack. And if somebody wants to make an attack on and alter the blockchain, then it has to do at least for more than 50% of the nodes, right? So that the majority of the nodes are modified. And since that is not possible, because that would be theoretically a possibility, but practically it would be impossible to attack all the nodes across the globe and alter the blockchain. All right. So it has enhanced security. Next, next it has immutability, right? As I told you before, because of the way the blockchain and the blocks are constructed. If you just modify one bit in any of the transaction, that block and all the blocks which are created after that block, everything has no connection, and everything gets everything collapses, right? So once anything is logged onto the blockchain, it is practically immutable and you cannot alter it, right? Next is called transparency with anonymity. Now this is interesting because blockchain is a kind of, and there are different type of we'll go through there are different type of blockchain systems, right? And most of the time, if you talk about the public blockchain systems, right? Then in those systems, everybody is able to see that what transaction is happening between which two accounts, right? But at the same time, there's anonymity. Now this is interesting. Transparency says that means that everything is everyone can see what is happening in the system, and anonymity means that you are not able to uh, know who is who, right? So transparency with anonymity is possible. So most of the time it is called as pseudo anonymity. This is because though you can see that a transaction has happened between this account and this account, but you do not have link that this account is is connected to who, right? So all that you can see in the blockchain system is that something has been transacted. Let's say X Bitcoin has been transacted between block address between the blockchain address this, between blockchain address X and Y. But this blockchain address X belongs to whom in the physical world? You do not have that link, right? So that is why blockchain gives you pseudo anonymity. But interestingly, pay attention to this one, that you are covered only till the point that link is safe. Once that link is revealed that this account belongs to this person, then the system actually becomes the kind of a witness of everything that has been done with that account address. So this is kind of interesting to understand as well. Then another thing is that another advantage or a salient feature of blockchain technology is fast overall processing, right? As I told that in traditional systems, there are a lot of third-party intermediaries, and every intermediary takes some amount of processing time. So the overall time builds up. Here, the only time that will happen for the confirmation of a transaction is the communication latency. That means how much time it takes to put your transaction onto the blockchain system, and then the block mining time. That's the only latency, and that latency, or more or less, is very fine-tuned by these systems, right? For example, in a Bitcoin system, every 10 minutes you will have a new block, and in Ethereum you will have every 10 to 15 seconds you will have a new block, right? So they will keep on gearing and tuning the difficulty level so that the block creation times remains the same. So overall processing time is kind of very low as compared to traditional systems in blockchain. Now, another important advantage is non-repudiation. Since all the transactions that happens in the blockchain system are digitally signed, then you cannot say later at any point of time, no, this transaction was not sent by me. That is not possible, right? So, and that's what is called as non-repudiation. That means you cannot deny that that this transaction was not initiated and committed by me. All right. So because everything is being digitally signed in blockchain system. Also, the everything that is happening in a blockchain system is validated based on consensus, right? So a consensus actually has numerous advantages. For example, it allows blockchain to be updated while ensuring that every block in the chain is valid, right? Because it has been validated by all the nodes. So every block in the chain is a valid block. Also, this consensus mechanism incentivizes the miners for putting up their effort to to maintain the blockchain and to keep up their fair play, right? Because these reward system and the economic model that incentivizes the consensus is helping miners to not behave maliciously, right? Also, it does not allow single entity to gain a complete control over the system, because everyone has to agree. One person cannot have a control and cannot govern that these transactions have happened and they are all valid transactions. So it does not allow, consensus based validation does not allow a single entity to gain a complete control over the system, right? Also, uh, also if any node, any node or any miner in the system goes down, then this consensus base and this decentralized system helps in protecting or preventing the system from crashing, when any node goes down, right? So everything is decentralized and consensus driven. And last but not the least, the smart contract based automation, right? As I told in before, in centralized system the level of autonomy is minimal, but because of the smart contracts and its decentralized nature and the way they are created and deployed, uh, the entire system can be automated, right? For example, the insurance, the vehicle insurance and everything, they can be very well put onto the blockchain system, and the smart contracts can be created, and once this happens, then the insurance amount should be transferred, and so on and so forth. All right. Okay, so having said that, let's move to what are the types of the blockchain, right? So there are actually different types of blockchain. Most of the time, when we refer to blockchain, we actually talk about public permissionless type of blockchain, right? But they are fundamentally, there are four different types of blockchain: public blockchain, private blockchain, and there are two others which are called as permissionless and permission blockchain, right? So basically, public blockchain and private blockchain have a distinction based on who is maintaining the copy of the digital ledger, right? So if the copies of the ledger is maintained on the public servers, right, that means they are not under the control of any group or consortium, then they are called as a public blockchain, and they tends to be more open system, right? Whereas the private blockchain uh, systems are the ones where the ledger is distributed and hosted at the private servers, right? Or you can say a consortium of or a group of nodes which have which are controlled, kind of having a private control, right? They tends to be more closed system. All right. Whereas there are other two types of blockchain, which are permissionless blockchain and permission blockchain. So permissionless blockchain are the ones in which, as the name suggests, in which any node can join the system, and they are free to make read, write, and new content creation, that is new block creation and append operation. Anyone can participate. For example, blockchain or Ethereum, right? They are all public permissionless blockchain. If you have a massive computational facility with you, you can join, download the entire blockchain. As of now, it would be huge, but once you have the copy of the ledger with you, you can start mining and start participating in the mining process, right? Here there is no permission is needed to join the system, whereas permission blockchain, every node within the network is allowed, of course, to read, but the write operation is restricted, right? So only the trustworthy selected node within the networks are allowed to create new content and to append new blocks. All right, so having said that, I think now it is time to view the evolution of the blockchain. So as I told, the blockchain has not all of a sudden happened, I would say, in the year 2000, in the year 2008, and but it is a kind of a result of an evolution that has happened over the years. As we can see, it started in the year 1979, where the idea of public key cryptography came into the picture. And also in the year 1979, Ralph Merkle introduced the concept of Merkle tree, which is being used. So we have public private key concept that are being used, then we have a Merkle tree that we are using, all created back in 1976, 1979. Then in the year 1982, you know the Byzantine fault general problem was introduced and presented. By the way, there are different consensus algorithm. Due to the time restriction, I might not be able to cover all different type of consensus algorithm. So one of the interesting consensus algorithm is practical Byzantine fault tolerance consensus algorithm, which actually is based on the Byzantine general problem. And then you have Stonetta and Harbour, which gave the concept of time stamping for digital documents. And in the year 1996, decentralized storage systems were introduced, right? So the decentralized idea is not new. It actually was introduced, as you can see, long back. And then the proof of work consensus algorithm, which is being used. So what we discussed in the process flow of the blockchain, that every miner trying to solve a cryptographic puzzle by trying different value of nonce and getting the hash value that meets the difficulty level, is actually a proof of work consensus algorithm, right? And as you can see that Adam Back invented the hash cache and the proof of work algorithm in 1979. And then in the year in the year 2008, the pseudonym Satoshi Nakamoto actually published a white paper named Bitcoin. And in the year 2009, the first Bitcoin was mined, right? And the reward, as I mentioned before, that time was 50 Bitcoin, which was an enormous amount of money if you see the equivalent value of Bitcoin today, right? And the first transaction took place in the year 2010. And uh, if you talk about a Bitcoin system, then see, in the Bitcoin, you cannot introduce new Bitcoins externally. The system itself mints new Bitcoins every 10 minutes, right? Today it mints every 10 minutes 6.25 Bitcoins, right? And it will keep on doing this till the year 2140, right? By that time, all the possible minting of the Bitcoins will be over, and the last mining will be done in the year 2140, right? and uh, and I think you can do a quick mathematical calculations that how many Bitcoins will be mined by the end of the year, by the end of 2140, right? There is some definite value that the Bitcoin system will mine, right? So it has its own minting and governance that happens, right? And it is not affected by the outside world. It's those only Bitcoins which you can circulate and you can transfer. Interestingly, there is another as you know that there is another as you might have heard about before, that there is another Bitcoin system which is called Ethereum. And the Genesis block of the Ethereum was mined in the year 2015. And there is another so Ethereum is again a public blockchain system, whereas Hyperledger Fabric introduced by IBM, it's a private blockchain system, right? There's Hyperledger Consortium as well as the Hyperledger Fabric, right? Okay, so with this, I think I'm done with the part two, and then how far I can go now? Like how much is the time that I can go
Maybe we can go
accordingly? I'll
for
fine tune.
yes, until about 9 p.m. Now it's 8:38. So
All right. So then I'll go. We have about let's say I'll take about 20 more minutes. I'll talk about blockchain ecosystem, and then I'll be happy to take few questions if there are any. Right. Okay. So blockchain ecosystem. So what is blockchain ecosystem? So far we have understood the concept and the philosophy and how the blockchain system is actually kind of uh, created and they work. But then there is an entire ecosystem that works together, and you can create applications in this ecosystem, right? All right. So there are actually distinguishable role that can be played or that are there in a generic blockchain ecosystem. They are about 11 roles, distinctive roles that have been pointed out um, by Ryan now, and in this paper which is titled as the generic blockchain ecosystem and its strategic implications, right? So there are different roles. We can quickly go over all of them. So you have consumers. Consumers are basically the end users. They can also be the participants, which are the miners, which are taking part in the mining process, right? So all these different actors, they all work collaboratively to form an overall blockchain ecosystem, right? So consumers are actually the ones who are actually requesting for on-chain or off-chain hybrid blockchain based applications, right? They are the users, actually the end users of the blockchain ecosystem. So, by the way, the on-chain and off-chain and hybrid blockchain applications are there. On-chain means when you are putting everything on the blockchain, right? That means all the transactions, all the digital value, everything is being put on the blockchain. And once you start doing this, you would need a computationally intensive and the storage requirement would go very high very quickly. So the alternate to the on-chain is the off-chain applications, where you are actually all the transactions and all the digital values are moved off the chain, right? And their fingerprints and their fingerprints or their kind of essence is put onto the blockchain, right? Those applications are called off-chain. You may would like to explore more about on-chain and off-chain. These days much interest is there in creating off-chain blockchain applications, right? And there are hybrid as well, which makes a use of both on-chain and off-chain based blockchain based applications, right? Now there are the different infrastructure providers. Infrastructure providers are the ones which are actually providing the massive computational facility to mine and to maintain blockchain, right? So for example, the most popular one of course is the Bitcoin. So there is big Bitcoin infrastructure where you can transact other digital assets as well. There is Ethereum. By the way, Ethereum is the one which is now getting very popular, and it was actually founded by Vitalik Buterin in the year 2014, if I remember correctly. And it's one of the most popular open source public blockchain platform that supports smart contracts actually. So Bitcoin doesn't support smart contracts, Ethereum was a first, I believe, which allowed smart contracts and the creation of smart contracts and deploying of smart contracts, right? And surprisingly, I think you already know it, but it is not that much. Ethereum is not that much popular for cryptocurrency, but still, it is the second largest cryptocurrency platform after Bitcoin, right? And in Ethereum, the default cryptocurrency is Ether, right? And the programming language that is used for creating smart contracts in Ethereum is called as Solidity, and there is another one which they have recently proposed is Viper, right? These are the languages that helps you to create decentralized applications over Ethereum. The other interesting blockchain infrastructure provider is Hyperledger, and the Hyperledger initially started as a project by the Linux Foundation, and has been joined by so many other companies like IBM, Intel, Cisco, and many more, right? One of the most popular frameworks under this grand project is Hyperledger Fabric by IBM, as I mentioned before, which is actually a permissioned, blockchain system, and it allows smart contracts, and there it is called actually chain codes instead of smart contracts. And the languages that are used in Hyperledger Fabric are like Go, Java, and JavaScript for writing smart contracts, which are called as chain codes there, right? Big Chain DB is another infrastructure provider. So the blockchain database. Uh, this Big Chain DB, if MongoDB, if you remember, they are the centralized databases and all. So blockchain database was released. Big Chain actually is a blockchain database which was released in the year 2016. The idea is to combine the properties of blockchain and database world, right? And interestingly, MongoDB and Big Chain DB have collaborated to offer the salient features of blockchain, like decentralization, immutability, etc., on the top of MongoDB actually, right? Which is kind of a more mature technology. And another interesting player is you might be knowing is Corda, right? In this space.